In this video, I will show you what are the 3 easiest ways to connect to Windows or Linux machines from the internet through Jumpbox or a Bastion host. We're going to compare between connecting to a server directly using a public IP address versus connecting to our private resources using a Bastion host. And for this, we will use 3 different methods. The first method is to connect through a firewall doing port forwarding. The second solution will be using Fortigate, SSL-VPN web portal, and the third option will be to use Guacamole, which is a famous product that we can deploy on any Linux machine. Let's see how we can deploy these resources using AWS Cloud. And if you like this content, please leave a like and subscribe for more videos. Let's get into it. I want to start from my AWS account where I deployed a various servers on my EC2 service, and we have a Fortigate firewall, we have a public Windows server. This one was hosted on the public subnet and it already has a public IP address. And we also have a private Linux server. This Linux server is deployed on the private subnet and it only has a private IP address, as we can see in here. And finally, we have also another Windows server, but this one is only hosted in the private subnet, so it doesn't have any public visibility. So for us, the easiest way is to connect to the Windows server directly using the public IP address. We would just go and connect to it using the remote desktop. You can just open in here. In this case, we can just paste our password. And this way we can get a quick direct access to our Windows server. From our Windows server, we can try to SSH or connect to other internal resources in AWS. However, the issue with this method is that your server is always exposed to the internet without any protection. You will get definitely some brute force attacks or some people trying to mess with your server. Therefore, we need to put some kind of protection on this traffic instead of having our server publicly visible. So now let's try to destroy the server because we don't want to expose our resources directly to the internet. And now let's see how we can deploy our port forwarding solution first. In this case, I want to be able to connect to both my private Windows server and my Linux server through the internet, but not have these servers directly exposed to the internet. Now let's try to log into our firewall so we can deploy our port forwarding solution. And what port forwarding do is it allows the firewall to reroute traffic to internal resources based on a specific rule that we define. For example, we can have our users connect to this firewall public IP address, as this is the only publicly accessible interface right now. And we can have a specific rule that says if the port is 50,000, connect to this internal Linux server, and if it's port 40,000, redirected or rerouted to the Windows server. So this way we can overcome the issue of not having a public visibility on the interfaces of our other machines, but also, and more important, we can secure these resources using intrusion prevention system and other security features in the Fortigate so that we can have extra layer of security before we connect to our machine. So first, let's go into our policy and object and firewall policy. And let's create a policy to allow this traffic to go through. In this case, we will call our policy port forwarding. For the incoming interface, this will be the public interface in the firewall. This is the interface that has the public IP address. So it will be port 1 because this is where we deployed it for. For the outgoing interface, it will be the interface where it has the private subnet. So it will be the port 2. In this case, our source is going to be the whole internet. We cannot know the IP address in advance. We just need to allow to all IP addresses. For the destination, this is where I will configure my port forwarding rule. And this is done using the virtual IP feature. So now we need to create 2 different port forwarding rules, one for our Windows server and one for our Linux server. So to allow our Windows server that is privately hosted, we need to take the IP address that is assigned to this machine. And in this case, let's go back in here and say, this is our Windows server. And from here, we choose the interface for the public subnet. This is where the traffic that need to be rerouted will be received. Now for the IP part, this is where NAT will take place and the IP addresses will change during this process. So basically we are telling the firewall to accept the traffic on its public interface, no matter what the IP address is, and translate it to this IP address. So this will be our Windows server. So whenever a packet hits the firewall IP on this IP address, gets translated to the Windows server. But we can't just leave it at that. We need to make sure that we are defining the filter for the port forwarding to be a specific port. Otherwise we will break all traffic because we are port forwarding everything to the Windows server, which is not going to work. We need to only route the RDP or the remote desktop connection, which happen on port 3389. But to make it extra secure, we cannot expose this port to the internet as is, because there is a lot of scanners and host scanners that will try to hack and connect and brute force to your system. So we can try to mask it by choosing a different higher unusual port like 40,000. And in this case, every time we want to RDP to our machine, we can connect to the firewall IP address 313.102.251 on port 40,000. The firewall will change the packet and it will update the destination address in the packet to this IP address, and it will change the port from 40,000 to 3389, so it will reach our server normally in the end. And also we need to create another rule for our Linux server. So let's go ahead and copy the IP address of the Linux server as well. And from here we can create our second virtual IP address object. So I want to call this one Linux server, and we're also going to receive these packets on the public interface. In this case, we want to remap this traffic to our Linux server, but only when the traffic is hitting port 50,000 this time. This time we want to reroute it to the normal SSH port so we can SSH to our server. So now let's hit OK. And now we have our second virtual IP. We can just add this one as well. Now we can add this port in here. We have to add every single port we added, like the 40,000, 50,000, and the translated ports are also need to be added. So we can just say all for now. And then we can apply the IPS protection that we are preferring. I prefer to apply the high security. And then also we can apply application control to get more visibility, or antivirus. Now let's also log all session to make sure we have visibility onto who's trying to log into our system. And finally, we save our policy. Now, once our policy is saved, we can start directly testing our connection. Now let's paste the firewall IP address in here, and let's just define the port to 40,000. This is the same port that we defined for the RDP. And for the first time, it's going to fail because we failed to add a very important step, which is the EC2 security group. We have to come here to the Fortigate and we have to make sure we are accepting this traffic first in our inbound policy. As you notice, we are only open for the default ports. We do not have anything for RDP or 40,000, 50,000. Let's go to our security group and edit our inbound rules. We just need to allow the ports before they get translated. So we only need to add port 40,000, and we also need to add port 50,000. And we can accept those from all IPs on the internet. There is no problem. And finally, we just save it like that with all the rules. Now let's try it one more time. So now let's try our password for our private Windows server. And now as you see, I got access to my Windows server indirectly using the firewall public IP address. Remember, our private Windows server does not have any public IP address assigned to it, and therefore we allowed access to our server through the firewall with intrusion prevention and antivirus enabled. And this way you can quickly get access to your Windows server and access anything inside AWS from here as well. Now to connect to our Linux machine in the same manner using port forwarding, let's create a new profile using our Solar Body client. I want to call this one Linux port forwarding. And for this, we're going to connect to the public IP address of the firewall. We're going to put ec2-user at the IP address of the firewall for port 50,000. And finally, we can put our key file here. And this way we are connected to our EC2 instance using port forwarding and by not exposing our Linux machine to the internet either. Now this was the first solution to use port forwarding, and it's the more simpler option, but we also did not sacrifice security and we added additional features like intrusion prevention and antivirus. Now let's move on to the second solution, which is the SSL-VPN portals. And by creating SSL-VPN portals, we allow to create a login system and a web-based GUI that allows us to get access to certain internal resources and services directly using the Fortigate built-in web service. As you see, when we open SSL-VPN portals, we have two different choices between a tunnel mode, which is a full-flavor SSL-VPN connection using a client like a Windows application, and the other mode is web mode, which is the web-based version of this feature. And the web mode is good enough. It's going to allow us to do everything we need and connect to RDP, SSH, and even more. So let's try to modify this web access mode. So this one, let's call it jump box. This will be the title of our page. But the main important, we can create a predefined bookmarks. Those will be a quick bookmarks that will be shown directly to the user, so they don't have to put the IP address of the instance or do any work on their side beside the login credential that they have to input. So in this case, let's try to create a new bookmark. And we have here different services. We have RDP and we have SSH as we want. We also have additional services like VNC or Telnet or HTTP, HTTPS. Let's call this one Windows Server. And for the protocol, it will be RDP, and this is the IP address. For the port, it will be 3389. And for the single sign-on, this can allow us to log in using the SSL-VPN and then pass certain username and password to the system. We don't want to do this. We want to leave the user to log in by themselves. For the security, let's change it to TLS encryption to make sure our connection is encrypted. Now we have our first bookmark. Now let's add another one for our Linux server. So this one, let's call it Amazon Linux. And we're going to choose SSH in this case. And for this, we're going to choose ec2-user, which is our username, and then the IP address of the private Linux server. And now we have our second bookmark in here as well. Finally, there's an option for FortiClient. This is if you want to get the full flavor SSL VPN. We don't need this. We don't want to even give the option. We just want to save our system. So now we have our bookmarks ready in the web access. Now we can simply go into our SSL VPN settings. In here, we can actually set up our portal and how is it going to listen. So in here, we can enable this to happen on the public IP address of the firewall again, because this is the publicly visible interface. Now for the port, we cannot use port 443 because we are already managing the firewall using this port. So let's choose a different port like 4343. In this case, we have a unique port, so it's not gonna conflict. And then we can go down, and from here, we just need to enable the authentication or portal mapping. This will be the portal that we want to give. So in this case, we just need to allow this web access portal that we configured with the bookmarks. So now all the users will apply to this single rule. There will be no other rules. And now we can apply. Now our next step before we create a policy, we need to create a user so that we can log in using the portal. And for here, we can either use something like Active Directory login, or we can use some local users on the firewall. So let's go into user definition and just create a simple user locally on the device. So we're just going to create a simple user, test user, and we're going to use this to validate our SSL VPN portal is working correctly. We don't need to enter any contact information. We just need to submit our user. Now we have our local user. Now let's get into the firewall policy and let's create our policy. In this case, the incoming interface will not be the internet. In this case, it will be the SSL VPN tunnel interface. This is a tunnel interface or a virtual interface that is used to represent the user's login to the firewall using the web mode portal or the SSL-VPN client. In this case, our incoming interface will be the VPN. So let's call the policy SSL-VPN as well. And for the destination interface, that will be the interface that has our Windows server and Linux server. This will be our private interface. For the source, let's keep it open for all, but we're gonna also need to add a user. As you notice, anything concerning SSL VPN, you have to define the user. We can control it using the login process. And for here, we can just go in the user tab and choose our test user. For the destination, we only need to open access to the servers that we allowed before, so our Linux server and our Windows server. For the service, it will be the same ports that we use to connect, so it's going to be RDP and also SSH. And this way we can allow our traffic to go through. And finally, we can also enable IPS and antivirus. Change this to high security, log all session also. Now our policy has been created. So we need again to go in the security group, go in the inbound rules, and also enable a second rule for port 4343. And add our subnet as well. Now let's go into the firewall and take the IP address. But instead of going on port 443, let's go in 4343. And this way we will get the Forti authentication login. In this case, let's use our test user, login name and password. And once we log in, we will have our quick shortcuts like the Windows server and the Amazon Linux. And this way, if we come here and enter our password and we log in, we're gonna get this convenient access to our RDP instance through the browser directly without having to expose our Windows server to the internet as well. We can do the same thing with our Amazon Linux, and it will open for us the login credential, but we did not set a password for this Linux machine. We do not have a password, we only have the key file. We can change that, but we just proved that we can have access to the server and RDP directly using the SSL VPN portal. Now let's get into our third and last option, which is to use Guacamole. And Guacamole is one amazing piece of software that is open source, and you can install it in any Linux machine or even in a Docker container. And it allows you to quickly get access to your internal resources as well using a jump box or a Bastion host that you set up on your edge or your internet parameter. So let's say you are not using Fortigate. Let's come here and just tier this instance completely. And now we just want to depend on our Guacamole to deploy our resources. So let's try to launch Guacamole, and I will show you how quickly you can use Guacamole to build your Bastion host. Once you search for Guacamole, you will find a Guacamole Bastion host image directly by Netcube and also by Bitnami. So I prefer the Bitnami version, and we can select this one. And we can put it on even a simple machine like a free tier eligible. In this case, let's make sure our interface is built in the public subnet so that it would get a public IP address. Let's make sure we assign it an IP address as well. And we don't need anything else in here. We just need to launch our instance. So now once our server is ready, let's open it using HTTPS and the IP address. And this will show us the Apache Guacamole login screen. The application is already pre-packaged in this image, so we don't have to install it from scratch, which is also fun to do, but in this case, it was already made for us. Now to get the login credential for the Guacamole, let's go back to our Solr body and let's create a new one for Guacamole. In this case, we're gonna use Bitnami based on the instruction they provided, as the username and IP address will be the public IP address of the Guacamole server. And finally, define our private key file. And now we can connect to our Guacamole server. Directly in the first directory that we are in, we have a file called Bitnami credential. This has the password to our login. We can just use Nano or any text editor to open this file. This will show us guacadmin will be our username. and this will be our auto-generated password. And once we log in, this will be our connection screen. Right now we don't have any connection. Now once we disable the NLA authentication in the Windows server, we can now come and start adding our profiles in Guacamole server. The way we do this, we open our menu, go in the settings, and we need to go in the connection tab and start creating our first connection. Let's first start our Windows Server 2019 profile. We're gonna connect using RDB, and for here we can define the maximum number of connection to 1. Now going down, we need to fill up the IP address of the server, so we can go ahead to EC2 and grab this using the private windows, and we're gonna paste the IP address in here. For the port, this will be 3389. For the login, we will use administrator account. We can even simplify the process by putting our password in here, and this way it will automatically log in. But main important with newer versions of Windows, especially Windows 10, Windows Server, you have to change the security mode manually to TLS because this is the only way RDB will work. And finally, we need to ignore server certificate as well. Now everything in here is ready. We can go ahead and save our profile. Now we're going to create our second connection for our Linux server. This one we will connect using SSH protocol. And we need to go in here and grab the IP address of the Linux server. We can put the IP address of the Linux server in here. For the port, we will use port 22. We can simply put our username ec2-user, and then we can go down and save our profile. Now we have our two profiles ready. Now in order for us to use them, we can go back to our home screen. So to access our Windows server, we simply click here. It will directly jump into our Windows server from our Guacamole web GUI. We can use the server as normal. It's going to be very smooth, as good as the RDB client, if not better. Now if we try to access our Linux server, it will ask us for the password, and we are able to access our Linux server from the Guacamole server as well. And those are the three ways that I use to set up a Bastion host using either port forwarding or SSL-VPN portal or Guacamole. Thank you for watching.